Picking up where we left off in the last video, we have one last practice problem here for molarity. And this question asks, how many liters of a 0.125 molar sodium hydroxide solution contain 0.255 moles of sodium hydroxide? So if you would like to check your knowledge from the last video to see if you can still solve these things, go ahead and pause the video now, try to work that out, and then come back and we'll work it through together. Alright, we're trying to find a number of liters. We're told that the molarity is 0.125, and we're told that our solution contains 0.255 moles. So this is going to be pretty straightforward, actually, if you can remember that the molarity is equal to the number of moles divided by the liters. We're really just trying to find this, and we're given the other two. We're told what the molarity is, we're told how many moles we have. And so all we're going to have to do is a little bit of algebra to solve this. So if we go ahead and plug in what we know, 0.125 moles per liter is equal to 0.255 moles divided by the volume in liters. And so if we want to get that liters by itself, we can't just divide by 0.255 because that would give us 1 over the number of liters. And so what we're going to do instead is we're going to multiply both sides by the number of liters and divide by 1.25 molar. And so that's just going to make this whole thing go away, and the liters over here go away, and we'll be left with the number of liters is equal to 0.255 moles divided by 0.125 moles per liter. So those moles are going to cancel out, and if we do that math, it's going to be close to 2.04 liters is the volume. So that would be the volume of that solution, given that we had 0.255 moles and the concentration was 0.125. All right, I hope that made sense. Moving on now, let's talk briefly about actually preparing a solution from solid reagents. So if we're actually going to make a solution, let's say that we wanted to mix 1 liter of 1 molar sodium chloride, and we wanted to start with water and solid sodium chloride. We just had some salt from a salt shaker somewhere, and we want to make 1 molar NaCl. How would we do this if we were actually going to do it in the lab? And it's actually pretty straightforward. Although the pictures that are shown here, that is obviously not sodium chloride. That is not salt water. You know, the ocean does look blue, but that's for a whole different reason. It's not because there's salt in it. So that is actually copper sulfate, I believe, but we can still get the point across, even with a different solid. So the way that you would make a solution like this is if you know the concentration you want, and you know the volume that you want. So you know this, and you know this. Then what you need to do is you need to work out, okay, how many moles of the material do I need to accomplish that? What would be my N value here? What's the number of moles? So you'll find that number of moles, convert it to grams. And you would just weigh out that amount of material. That's what they're doing here. So you would weigh out, in our example here, you'd weigh out 1 mole of sodium chloride, which I want to say is something like 54 or something like that. 58, I guess, because sodium is 23 essentially, and chlorine is 35, so it'd be 58-ish grams of that material. When you have your 1 mole of the material, you put it into what we call a volumetric flask. And so a volumetric flask has just one marking on it. It has one mark because it is only meant to measure one volume. It's not like a graduated cylinder where there are markings all the way up the height of the glassware. This has a single mark right there. And so that one mark measures to 4 sig figs the volume that it's made to measure. In this particular case here on the picture, it's 250 mils. So this would weigh or would measure 250.0 mils because that would have 4 sig figs. Volumetric flaskware is always meant to measure 4 sig figs of precision. So for our purposes, with 1 liter, we would have 1.000 liters. If we put the water with the meniscus right on the 1 mark. And so what we would do is we would put that 1 mole of solid into the flask, and we would start to put the water in. We would not immediately fill it to the line, because what happens is if the salt doesn't dissolve quickly, which most salts don't, most salts take at least a few seconds. Some salts can take like up to a couple hours even to dissolve. Sodium chloride's a bit faster than others, but there are some salts that can take a really long time to dissolve. And while they're doing that, they are actually changing the volume. So if you just dump in a liter of water, you're going to end up with like 1.1 liters of solution or something like that. Maybe not quite that extreme, but you're going to end up with more, a larger volume, because as the salt dissolves, the solution does actually expand. So you do have to kind of, not super slowly when it comes to sodium chloride anyway, but you do have to kind of add some, mix, 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 add some more, mix, 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 and then usually after 2 of those mixing periods, it's mixed enough to where you can go ahead and fill to the mark. But that is how you would make a solution. Figure out how much of the solid you need, put it into a flask that measures the volume you want, and then using several steps, add the water until you get to that volume. And that's how you would make a solution from reagents, from pure reagents. I had intended to go into dilution in this video, but I think actually I'm going to go ahead and leave that for its own video here. This is kind of a, sorry to make like long video, short video, long video, short video, but I think if I go into dilution now, this will end up being another really long video. So I think we'll go ahead and call it here. And the next one we'll jump into solution dilution, which is the last big topic of this chapter. And I'll see you there.